Welcome to a new test and teardown video. Look how lucky I am. Another one with Nixie tubes. And those are really nice and big ones. And a lot of them. So this is a Philips PM2441. It's a digital voltmeter. And the only thing this can do is volt, actually. And it is nearly 10 kilos. It's huge and heavy. And it can do all sorts of input on the front and input on the back, and also input via a module. A little bit of a dodgy contact here. And the start-stop of the AD converter, and it can be remote controlled. That one seems to be working too. Let's look at the back. So this is the back panel. We can see the type number. It's 2441-04. So I believe we got a lot of different versions of this one. It was sent for service in 1975. And I believe this model is from about 1970. There's another analog input right there, module input as well. And look at all that, remote control and digital output, external start pulse, voltage regulator, fuse and different voltages. Also, I believe this is in a sort of a standard cassette holder for the unit, because it looks like, yeah, let's have a look at that. So if we put it on the side, look at that. Yeah, exactly. Whoa, that slides out. Oh, nicely. Oi, oi, oi. That is some beautiful. Look at that PCB layout, and it's really, really nice and beautiful. Got some isolation there, and cables are really nice as well. Hey, let's have a look on the other side. That is absolutely impressive. I think I now know why I can't find a lot of info about this unit on the internet. This is because this unit was very, very expensive and special. So there were not a lot of these around in the 1970s. Wow, man, look at that. And what have we got? Here is a special module. And there's also some special stuff in here. We need to have a look in there as well. And that will be shielded Teflon cables. And down here we see direct driven Nixie tubes, because we see individual 74141s. That will be Nixie drivers. So now you know how many tubes we got. 7 tubes. And what is that? It feels like a total solid module. And this is the power supply, so maybe this is the transformator or something. But what is this module then? So I bet that will be a power supply with all sorts of regulators and stuff. Digital output, counter memory, oscillator, crystal, program, remote control, relay driver. Ooh, I can't wait to see what happens when I power this up. How about we do that right now? All right, let's power up. The input voltage is applied, and when I hit this one, ooh, Zero, zip, nothing. Okay, we got a fuse blown. At least. Oh, damn it. I had a lot of problems getting this to work, and it turned out it was actually the mains on-off switch that was defect. I think the lever here couldn't move correctly, and also this holding and switching mechanism didn't work. So I cleaned it completely and lubricated it again, and now it's actually working really good and nice. And same with all the other switches. I had no good contacts in them, and the instrument wasn't really working. So again, a complete clean and a new lubrication, and see, now it's all working nice and stable. And those contacts also completely annoying. So now this is cleaned, and here is the Nixie module. It is in this socket. There's actually another socket here at the back, and you need to take care of a lot of screws to hold the front plate like this, and some washers and spacers and all sorts of stuff, even isolated washers, because we got some tracks. It looks like they kind of found out a little bit too late, and then you need to put in a little isolation washer. So what I found out here, look at that, all those 74141s, and they're not driving Nixies, all of them. See, some are actually driving neon bulbs. That will be the volt and the millivolt indication. And then we got 4 of them. They are fully driven. And the last one to the left, that one can only write a number 1, I guess. And that one can do plus minus. So that is kind of what the Nixie module can do. Before I put this back together, I will carefully clean the glass so it is nice and shiny. If we look at the red filter, look how dirty that is. If you touch this, you can see there's a thick layer of dust on the filter, so that needs to be cleaned. So that is nice and fine. I glued all the text back on all the plug-in modules, and this machine is just completely full of plug-in modules. Look at that, and it's packed to the last millimeter here. All those modules and all the labels here, they were falling off, so I glued them so this is nice and beautiful. And I found out, because I found the manual, and I will link to the manual in the description if you want to know a lot more. But we've got 2 transformators. One is the mains transformator, and then there's a winding to another transformator for all the other voltages for super isolation and whatnot. And it is a very complex unit. Look at all that stuff. Program, what is that? Oscillator counting memory. That's actually 4-bit 2x2 latches. So that means it can show the previous result on the Nixies and then count, because it's dual slope conversion, and then it will count the next value in the background and then flip over to the new value. So this is what it's doing with the counter memory. We got both of the digital input and remote control options. They are actually installed in this unit, and that will be those 2 connectors with wires to those 2 modules. So nice, we got all the options installed. So now it is a little bit pre-assembled, and I will be ready to test and see if I can get this to run a little bit better. It's actually a little bit difficult to assemble and disassemble this thing. So look how they made everything in more layers, and then they will connect here, and then you need to screw here, and this screw is hidden here, and you need to turn this to access the screw, and God know what. It's a very mechanical challenge to to do all this, and all the screws here, and you need to have a little washer, and where's the nut, and hold that, and in here, oh, let me show you guys, this is so difficult. So when those go back on here, you need to have 2 or 3 different washers, and the nut down here, and over here we need to have a little isolation washer, because of this is a little bit stupid. See, there were plenty of space here to move all those tracks a little bit, right? But nope, that is a little dummy. Yeah, we got some screws here as well. I am actually really happy about this instrument now. Look at that, 1.9040, right? I mean, that is more or less the same, right? And it's the same in all the other ranges. So this is the 20 volt range, and it's the same. So I fixed all the ranges. So the 200 range should be a little bit higher, but when I give it more input, it actually goes accurate. And this is 1.8. It should actually be 1.9 in the 1000, and it's super nice. And this one can actually go to 2. So that means when it is 2 volts, let me try and do that like this. Then it's just 2 volts or over. Then nothing else happens. So what happens if I go to, look at that, huh? Auto range works as well. No matter what range you are in, you can always just go to auto. So that is absolutely fantastic, this meter. You know, it's because all those ranges they're handled by relays. See what happens when I clean this. Oh, that is difficult. Oi, 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 oi. Now it's looking really nice, right? Then I just need to mount the front. Let's look at a little bit at the modules. I can't take all the modules up because we got some wires going in and stuff, but I guess that will just be some AC signals, and that will be some rectifiers and some different voltages made special to the ADC. And the next module is the ADC. Look at that one. Look at the wires. It's here in the middle of the picture. Look at the wires for that thingy. Isn't that just fantastic? I mean, okay, they made the PCB layout and they couldn't get exactly the right thingy here. Oh my god. And it's just almost touching, but so this is how we do it. Oh yeah. There's a beautiful 2-layer PCB. I mean, this unit must have been very expensive. It is really a masterpiece of design and manufacture. I can't get that module up because I got some wires here and I really don't want to screw anything up. But this is a DC amplifier, but what it is really, you see here the chopper. So this is an opto-coupler chopper. This is of course also explained in the service manual. So please dig in to the service manual if you want to know a lot more. I will link to it. Range switches. Yeah, I wish I could take this up because this one is full of relays. and they were going absolutely nuts before I cleaned all the switches. It's just this whole board is full of relays and resistors and whatnot. Relay driver. Let's have a look. So this is the relay driver. All I see is some gates and flip-flops and stuff. Not exactly what I expected. And this is the remote control board. I think, oh, that is not so easy to pull up. Ooh, that's some special ICs. It's just a parallel interface. Some diodes here and stuff. Not very interesting. Yeah, here is one. This is called program. I don't know exactly what that is. What, some gates and some, yeah, just a lot of NAND gates. Oops, and a counter and stuff like that. Yeah, flip-flops. But look at that, is something interesting. Here in the middle of the picture, can you see between the two gold contacts? You see what they did here? They filled up with epoxy this gap they made the wrong place. And here as well, just to the right side of the wanted gap, there used to be a gap, and they didn't want to have this gap there anymore. It's because the bottom contacts here, see? They're coated, so you can't plug in modules wrong. That is really smart. But they kind of misfigured this out, and then, oops, let's fix it again. Yeah, I want to show you guys this. This is the oscillator. So there's a crystal, and then it counts and flip-flops, and yeah, quite a lot of counters here to make all sorts of different frequencies. And also I'm a little bit curious about that transistor. Look how black that is. But everything here is working. Of course, it's a Philips crystal. Yeah, and that was the counter memory I talked about. Here we go. The 74116. Yeah, that is a dual 4-bit latch. So that means here we got all the counters. Yeah, 7490, 7490, 7490, la 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 la. So they're counting all the time for the dual slope, and then swapping from the live count to the result using those latches. Really good. And then there's a digital output. I don't think so. There's not a lot more to show you guys. We've been through everything here. A classic power supply, but what is that? A very long, sexy resistor thingy. That blue one, what is that? Hang on, I gotta check this out. What is that? Okay, we got some op amps and some transistors, simple stuff. So this is the U2 module. I will look this up. So here we go. This is the U2 power supply module, and this is R202. That's what it is. So this is the schematic for the U2 power supply module. We've got some rectifiers, op amps with feedback for some NPN transistors, pretty basic. And then we got the 5-volt supply. Is using the big rear mounted transistor. And then R202 is a sense resistor of 0.12 ohms. So it's current measurement or current limiting. So that is what it's doing with the power supply IC202 All right, great. So now we know exactly what to expect. Oh, there's a 2 amp fuse for the 5 volt supply.